Today we are going to look at measuring and constructing segments. So let's go ahead and jump in and get started. First, let's talk about segments themselves, and when we refer to distance, what are we actually referring to? Distance is the absolute value of the difference of the coordinates of the point. Now that sounds a lot more complicated than what you're probably used to. If I asked you, what is the difference between A and B? Go ahead. Take a second and see if you can tell me what the difference between A and B is. My guess is what most of you guys did was counted. 1, 2, 3, 4, 5. So you told me that the measure of AB is 5, and that is 100% correct. You can also look at the definition. So we want the absolute value, so our absolute value signs, of the difference of the coordinates. I have two coordinates here. I've got a -2 and a +3. So I'm going to find the difference between them. Difference means subtraction. So -2 minus 3, absolute value. So I want the absolute value of a -5. Absolute value always evaluates as a positive number. Now it doesn't make a difference of which number you subtract from the other. If I went the other direction and did 3 minus a -2, minus a negative means I'm adding, that gives me the absolute value of 5, which once again is going to give me a +5 answer. So as you guessed from the very beginning, the distance or the measure of segment AB is going to be a +5. Now, a bunch of notation in this chapter is going to come up. When you are writing or you're answering a question, if you see a segment AB written without a line above it, that means that we're wanting to evaluate what the measure of that segment is going to be. I want the distance. Now, if I write AB with the line above, that means I'm naming what the segment is. I'm talking about the segment itself, not what the measure of the segment is. So just keep that in mind. So let's go ahead and get into some examples with drawing and some more vocabulary. I want you to draw D between C and E. So go ahead, again, take a second and set up your diagram. Draw D between C and E. Go ahead and pause. Now, since D is between C and E, I'm just going to put C here. I'm going to put E here. I don't know where D is falling in between C and E. I don't know if it's closer to C. I don't know if it's right in the middle. I don't know if it's closer to E. So this picture isn't necessarily going to be accurate. You're just going into this blindly. In geometry, very rarely do you ever have an accurate diagram because most of the time you're drawing something to figure out what your numbers are, so you can't accurately portray that picture yet. So in order for D to be between C and E, the 3 points must lie on the same line, being collinear, one of those first vocab words from our chapter. Big idea to remember is that between does not mean middle. It doesn't mean that I'm cutting it into two congruent pieces. All it means is it's going to fall somewhere in between. So I'm giving you the fact that DC, the measure of this segment, is going to be 8. And I'm telling you that the measure from C all the way to E has a measure of 21. Now what I want you to do is find the length of DE. I want you to find the length of that segment. What do you think? Go ahead and pause and see if you can find out what DE is going to be. So if you think about it, if the whole segment from here to here is 21 and this part is 8, to find our missing segment, I do 21 minus 8, and you should have found that DE was equal to 13. Now before we move on, I just want to make note of something real fast. I asked you, what is the length of that segment? Oh, there was the bell. So what is the length of that segment? I also could have taken that question and I could have just said, what is DE? Without the line above it, I expect you to know when I say what is DE, I'm not asking you for you to tell me it's a segment. I'm asking you what is the length of that segment. So just be aware that these two questions are expecting the exact same answer. Okay, moving on. Segment addition postulate. So if B is between, again, there's that keyword there between A and C, that means AB plus BC equals AC. It's a lot easier if we draw a diagram here. So B is between A, C. All that's saying is that it's saying that if I take this segment AB and I add it to segment BC, together they create the whole AC. So part 1 plus part 2 is going to equal the whole, which makes sense. Together they create the entire piece. So our next example, example 3, M is the midpoint. So now we're finally getting a vocab word that's going to give us a little bit more information. It's the midpoint of AC. The midpoint is the point that bisects or divides the segment into two equal pieces. We're not going to look at the patty paper since I'm not here today, so the patty paper demonstration will be another day. Let's just go ahead and look at what the midpoint is. So again, it's going to bisect or divide it into two equal pieces. So if M is the midpoint of AC, it's the halfway point. Two equal pieces. That means that whatever this piece is the same as this piece. These two pieces have the same measure. So if this is 5, this is 5. If this is 8, this is 8. They have the same measurement. If they have the same measurement, that allows us to set up an equation. If they're congruent, they're equal. So I know that 3x minus 2 is equal to 2x plus 4. Knowing that relationship, again, allows me to set up the equation. The fact that they're equal means that I put an equal sign between them. Now I'm going to go ahead and solve for x. I always move the smaller x to the other side to keep my x's positive. Then I'm going to isolate my x, so I'm going to add 2, and I find that x is equal to 6. But that's not what the question asked. The question wanted me to find AM, MC, and AC. So that was only the first part. Make sure, especially on quizzes and tests, that you read the directions and you're answering the question. Sometimes we solve for x and then we think we're done. So we plug our x in. We've got 3 times 6 minus 2, 18 minus 2 is going to give me 16. Now I know that since they're equal, this should be the same, but I'm just going to double check to make sure I didn't do my math wrong. And if I get a different number, I know I made a mistake somewhere. So I've got 2 times 6 plus 4, 12 plus 4. That's good, that gives me 16. So I've got my first two pieces. I know that AM is equal to 16. I know that MC is equal to 16. But now I need to find AC. I need to find out what the distance is from here to here. This time I wasn't given an expression that's going to allow me just to plug my numbers in like I did for AM and MC. But if I go back to my segment addition postulate that we talked about up here, this segment plus that segment together equals the whole. So together AM and MC is going to give me the entire segment. So the measure of AC is going to be 32. All right, one more example for our front side. We're given that M is the midpoint of segment AB. What you should be working on is anytime you're given a piece of information, and in this case, the fact that it's a midpoint, as soon as you're having something that's going to help you, mark your diagram. If you don't mark your diagram, you're going to forget all the relationships. So as soon as I read the fact that M is the midpoint, I'm going to mark that piece as congruent to that piece so I don't forget and that it helps me later. knowing that I want to solve for x. So I have that AM is 2x. I have that the whole piece is 10x minus 18. I need to solve. In the last one, all I did was set the two pieces that I was given equal to each other. So my guess is some of you are just going to take the 2x and the 10x minus 18, and you're just going to set them equal to each other. Hey, just take the two pieces we've got, see what it gives us. But I can only set things equal if their measures are equal. And if I look at this, is my segment AM, is that have the same measurement as AB? No. So I can't just set those two equal. I can only set them equal if they have the same measurement. Now I'm going to use that midpoint fact. I gave it to you for a reason. That tells me that these two pieces are equal. So there's two ways that you could approach this. Since these are the same, if this is 2x, this is also 2x, then I could use my segment addition postulate. 2x plus 2x, together those two pieces add up to the whole. So these two pieces together equal the whole. Or, since I know that they are congruent, you could look at it, instead of adding it twice, it's going to take two of those 2x segments to equal the whole 10x minus 18. Both setups give you the exact same answer, so it's whichever one makes sense to you. Which one do you understand? So either way, we're going to end up with 2x and 2x gives us 4x equals 10x minus, oops, I said the right number but wrote the wrong number. It's going to give us 10x minus 18. We move that 4x over. That gives us 0 equals 6x minus 18. I'm going to move the 18 over. So now I have that 18 is equal to 6x. We divide by 6, and we have that x is going to be equal to 3. In this case, that's all I was asking you to do, so you don't have to worry about plugging it in and solving for the lengths of your segments. So just be careful and make sure that you're reading the directions so that you know what I'm looking for. Go ahead and turn your papers on over to the back side. We've got example 5. Example 5, M is between K and N. Km is 3x plus 2, Mn is 18, and Kn is 5x. What I want you to do is press pause, and I want you to draw a figure representing the situation. So I want you to plot your points, label each of your segments. So I want to see if you can get your diagram set up correctly. So again, press pause and go ahead and do that. All right, so first thing we're going to do is check that setup. I drew M so that it was between K and N. Notice that it just says between. It did not say midpoint, so I don't know that those two pieces are equal to each other. All I know is that M is somewhere in between. And then I labeled the sections according to the information I was given. All right, now what I want you to do is I want you to press pause again and see if you can write the equation needed to solve for x. So how are these individual pieces related to each other? Go ahead and press your pause. Okay, so we're going to use the segment addition postulate. In this case, our small piece plus our small piece gives us our whole, which gives us 3x plus 2 plus 18 is going to be equal to 5x. All right, we're going to pause again. Go ahead, and now that you have your equation set up, see if you can do the algebra on your own and solve for x and find your missing links. All right, let's see how you did. This could go quickly. If you made a lot of mistakes, go ahead and pause now, check your work and see where you went wrong. But I want to make sure that we understand if you got the setup, if you got the diagram, that means that you understand the geometry part of it. If you were not able to solve for x and you were not able to plug back in for km and kn, that's the algebra part. So if you're getting something wrong or you're struggling, think, where do you need your extra help? Are you not understanding the geometry, or are you not doing the algebra correctly? And that will help you troubleshoot and fix those little mistakes so that you can get them correct every single time. All right. Next part is talking about labeling. Congruent segments are segments that have the same length. So MN we have marked as congruent to OP. They are congruent because they have the same length. One has a length of 5 and the other one has a length of 5. So when I write that, I could say that in the diagram, the measure of MN is equal to the measure of OP. 5 is equal to 5. Or I could say that the segments are congruent. So measures are equal, segments are congruent. And that's the congruency symbol in case you've never seen it before. It's got a little squiggly above the equal sign. So again, just remember, lengths are equal, segments are congruent, terminology and vocab for you to use. When you are marking up your diagram, which we're going to be doing almost every single day, we're going to use different tick marks to show that they're congruent. In this case, I used just one line. I could use 2 lines to mark them congruent. I could use a circle. I could use a squiggly. I could use a triangle. I could use 3 lines. So it doesn't matter what your tick mark or your indicator is, as long as you use the same indicator on both diagrams. All right, the last part here, example 6, is how to construct a congruent segment. If you are still struggling with this construction, what I want you to do, because you're not going to be able to see the protractor and the compass on the video, is log onto your Canvas account, and there's a link to a video that will demonstrate this construction that we did in class yesterday. All right, and that means that we are done with our video for today.